Okay, guys. Since the UCSF Chimera molecular dynamics simulation actually crashed for the Wednesday class I was teaching, I decided I was going to make a video on the use of UCSF Chimera and how you can be able to use it to dock proteins using small molecule. So you go to files, you click open. Once you go to open, you try to locate the protein. This is the protein, the A2A. You click on it, then you open it. This is our protein, right? The A2A protein. Now, the next thing we are going to do is that we are going to look for the binding pocket of the protein where the small molecule will be docked into. So I'm just going to look at the amino acid residue and its number. The active sites, the binding pocket of the protein is from 167, the 167th residue to 173 residue. So yes, this is the 167th residue. So I'm going to press on Shift, Control, and then I'm going to click on it to highlight the protein. Then I'm going to swirl it around to get the entire residue that comprises the binding pocket of the protein. Okay, so it's from 167, sorry. Yes, 167, residue 167 to residue 173. That is the binding pocket of the protein. So the next thing I'm going to do is that I'm going to go to actions. Since it's highlighted, I'm just going to change the color. Maybe I will change it to orange red. You can see the binding pocket is already orange red. So the next thing I'm going to do is that I'm going to clear the selection. Then after clearing the selection, I'm going to go to File, Open, and then I'm going to fetch the small molecule, which is the caffeine. Here is the caffeine. So you can see the small molecule. So the next thing I'm going to do is that I am going to freeze the protein, and then you can see the small molecule is moving. So the next thing I'm going to do is that I'm going to go to Select Chain. Then I'm going to select the caffeine. Then after that, I'll go to Tools, Movement, and then Movement Mouse Mode. Then Move Molecule. Now I can be able to move the molecule. So the next thing I'm going to do is I'm going to drag the molecule to the active site of the protein using the option command. You can choose to unfreeze the protein so that you can be able to drag the swirl the protein around. So I'm going to drag it's still not there yet, right? The options command. Now I think the small molecule is actually bound to the binding pocket. Let's make it more closer. As you can see, it's in the binding pocket of the protein, as you can see. So the next thing I'm going to do is that I'm going to go to select, then clear selection, so that I remove the highlight from the small molecule. Then the next thing will be to carry out the molecular dynamics simulation. I'm going to go to the molecular dynamics ensemble analysis, and then click on molecular dynamics simulation. Once I click on molecular dynamics simulation, under select module, sorry.
Deal. Alert. Chief, real now, man. Of course, no mistake. I just want to let you know that I'm going to start cross-referencing forensics from both of my sides to establish pattern. Pattern? What the hell is Morrison and his wife got to do with an out-of-town and some fella you probably diddling with their own? So that's what I want to find out. These killers...
I think I need to highlight the caffeine. Once I highlight the caffeine, then I go to molecular dynamics and ensemble analysis, then molecular dynamics simulation. Once I go there,
I think that takes priority. Or did they do things differently up there in Massachusetts?
sorry.
She was trying to frame Morrison, and that's revenge for her. Just set me off and chase my tail. Told you it's good. I'm prone to agree, but incompetence can look like malevolence, and it's a whole lot more common.
So I'm going to select the
One of those conspiracy nuts.
Guys with the kind of money and power climb the rules are rarely dangerous. We can look into it.
You want this town to hate you more than it already does? Discuss with your client, and I'm not going to give a look into anyone except the losers and Morrison's old case pals.
Now that's what you're pretending to do. Roscoe too. So let's cover along with the real names. Like Joe's rental car. Must have had one of the homes of Mercy.
And they have assignments now.
molecular dynamics.
The next one has to do with Hubble's wife and kids. They need protection, even if Hubble's already dead. These guys get hit, and Charlie has even a 1% chance of knowing anything. Not good.
FBI buddy, wanted to reach out to her. Name's McCart, I'm in the field office. Recording this up. Got one.
Who we trust McCart?
Known him for years. He's the best advice I forgot. Don't take the marketing job.
Mr. Reacher, I'd like to offer my apologies for your arrest. My condolences for your brother. Tragedy when a person is struck down in his prime like that. My hand to God will find the killer. We'd be happy to keep you updated on the investigation. Just need your contact information for the department before you leave there.
I'm not leaving.
Oh, from my understanding, you were just passing through.
You understood. I figured I'd stick around a while. Margaret is such an interest.
So I'm going to select the caffeine because we are interested in the small molecule, since the caffeine is what interests us as a chemist. So we go to neither memorize or use memorized option. I'll click on run parameters. Then here I'm going to go to equilibration first. Once I go to equilibration, I will just assign an arbitrary value at the end of this in order to, differentiate. Sorry, differentiate
about me, Mr. Wilson?
Worried about my bottom line? You might need another shave before you leave town.
Very true.
My husband trusted Rich. He's a good person. I think so.
So
I
he,
don't know what you're listening to right now, but bad things are happening.
I don't know why he's doing it like that.
Bring here.
So put them together, get bags for the kids.
Where are you going?
Better call from Finland. Yeah, Agent Ed Picard is on his way. He's taking you into protective custody. Without a murder.
So after you've chosen equilibration,
We'll save
here,
if we stay with the two.
the output trajectory file, you try to add an arbitrary value before the .nc. Here I have added 2 to it. Then the next thing I'm going to do is that I'm going to go to production. Now the output trajectory file again, I'm going to add arbitrary value to it before the .nc. And also the output restart trajectory file, I'm going to also add 2 to it before the .nc file. Then I can easily now, switch back to minimization. Once I've switched back to minimization, then I will run it. All the default settings here are okay. I will just continue to click on OK, OK, OK.
The wait's over. How long after you avenge yourself?
Oh, sorry,
Check me.
I think I have to.
Finally know which egg is left most. Reese's or Cadbury?
Choose one. I just go. It's already easy with Reese's and Cadbury.
Where were you? Give a four-word feminist manifesto. Toothless. I'm worth. I wrote that.
Okay, so now there you go. I have it now. This is the molecular dynamics trajectory. So what is going to happen is that if I open UCSF Chimera, minimize it, now this is the protein, right? You can see here is the potential energy at the step 12 of the gradient minimization. So the next thing I'm going to do is that I'm just going to play this so you can see how the movement of the atoms in the small molecule upon the binding to the protein. So that's just the basic molecular dynamics simulation. Then the next thing will be to go to analysis. Once you go to analysis,
You boys looking for a dance partner?
once you go to analysis, then to your plots, and you click on potential energy, you are going to see the interaction energy here. We can also look at the kinetic energy as well. This is the kinetic energy. The potential energy is the one on top, and this is the kinetic energy downstairs, down. All right, I think that's all you need to know. Thank you so much.